Okay, well, I guess we'll get started. So here's a warm-up that everyone can try. Just simply asking, these are two parallel lines, K and I, or it could be J, I and I though. Two parallel lines, K and I, and then a transversal line that intersects both of them. And what angles are equal to the measure of angle 1. And I see more people are still joining us, so and I guess I'll just take this time to kind of explain how this class is going to go. So similar to last time, this meeting is going to run out around like halfway through the class. So please rejoin once you get kicked off. And another thing is, you might notice if you look at the syllabus, this class is Angles of Geometry Part 1. And so with this class and with the other ones that have 2 parts, what's going to happen is that this first class is going to be more simple, like just the basic definitions and the easier problems. So probably might get through this one pretty quickly. And the next class will just be focused on just more challenging problems in the same topic. So this next class won't have that much of a lecture, so to speak. And so to preface this is also the only geometry class within this course. So if we do have extra time, I will be also going over some other things in geometry that you can expect to see. All right, so with that being said, let's go over the warm-up. The answer is 3, 5, and 7. Those are the angles equal to angle 1. I guess since I don't have anything written down yet about like terminology and stuff, I guess the easiest way to see it is just that if you approximate, these are the angles that look very similar to 1. And I think as many of you are probably familiar with, there are going to be more explanations to this. So let's move on to the next part. And so basic definitions. What is an angle? Well, you can consider an angle just this thing between 2 intersecting lines or rays. And this has a specific measurement, and usually we use degrees. So it's just out of an entire circle being 360 degrees. This is just relative to that. So a 90-degree angle is usually like, you consider like a benchmark angle, so to speak. This like right angle, it can separate if the angle is less than 90 degrees, it's acute. If it's more than 90 degrees, so this entire angle, that's a terrible drawing, but this entire angle would be obtuse. And so this in itself isn't very interesting. So I'll go into the more I wouldn't say like complicated, but the more interesting parts of angles is complement supplements. So a complement is essentially 2 angles that add up to 90 degrees. So if we take this right angle and draw a line through it, this angle here and this angle here are complementary angles. And so, for example, if this angle is, I don't know, 60, then this angle will be 30 because they have that up to 90 degrees. And so this means that that 60 and 30 are complementary angles. So, okay. And then for supplementary angles, it just means that the 2 angles, they add up to 180 degrees. So the two angles you see in this diagram are supplementary angles because they together they make up this line. And the line has 180 degrees because it's exactly half of an entire circle. So as I move into the part about polygons and with more lines and stuff, if you do have any questions or comments, please just say so in the chat. This is a course for you all, so it helps me like kind of plan on, not plan, but like it helps me know like what I should be focusing more on. So if you do have any questions, please share. And anyway, moving on to polygons. A polygon is simply just a shape with straight lines. So a triangle is a polygon. Pentagon is a polygon. This thing is a polygon. Literally any shape, closed shape with straight lines is a polygon. And as you'll see, these angles don't have to be less than 180 degrees. This one, this bottom one, it's more than 180 degrees in this angle. And the main thing to know about angles in particular for polygons is that they add up to a very specific number, no matter what their shape is, and it's only dependent on the number of sides. So as you might know, a triangle has 180 degrees, and a square has 360 degrees, right? And so, right, you might wonder why this is the case. And I'm not going to go too in depth with the triangle, simply because I think you can just take the triangle for granted. It's not really worth showing. I think that it's more interesting, especially when talking about polygons, to kind of start with a square and go to the ones with more sides. And there is this formula. So if the shape has n sides, then the total degree measure or sum of all the angles in the shape. So for example, square has 4 sides. So this n would equal 4 for a square. The total sum of the angles is n minus 2 times 180 degrees. So for a square, 4 minus 2 times 180, that's equal to 360. For a pentagon, 5 sides, 5 minus 2 is 3 times 180 is 540. And you'll see that this works for every single polygon, no matter how many number of sides. And I know this isn't a super formal proof, but I'll give you like kind of an example to show why this makes sense. So let's say we take a hexagon. It doesn't have to be regular, but this one is good enough. Essentially, for all these shapes that have more than 3 sides, you can always divide them into triangles like this. Just choose a vertex and connect it to these other vertices so that there are now 4 triangles instead of 1 hexagon. Since we know that each triangle is 180 degrees, and then there's simply 4 times 180 degrees total in this hexagon, because there are 4 triangles. And if you notice, every single angle in every single triangle is part of a bigger angle in that hexagon. So you're not like wasting any like angles in the triangle or whatever, meaning that you can simply just multiply 4 times 180. So this is where the n minus 2 comes from. This describes how many triangles you can kind of cut out or split the shape into. And the 180 degrees is simply the number of angles in that triangle. Does everyone follow? All right. So if that's okay, I want to quickly talk about well, how do you divide this by n? So if you take this new formula now, where you have original n minus 2 times 180 divided by n, this number is describing the angle measure of a regular version of that polygon. And by regular, I mean a polygon that has every side and every angle is the same. So a square is a regular quadrilateral. An equilateral triangle is a regular triangle. And a regular hexagon would be kind of similar to what I drew here. And since the top is the total angle measure and the bottom is the total number of sides, you'll see that, total number of angles, that's what I meant at the bottom. You'll see that this is simply just the angle measure of just one of these. So for a square, 360 divided by 4 is 90. For the hexagon, 720 divided by 6 is 120 degrees. This is kind of an easy way to find the angle measure. Okay, and last part is exterior angles. So with exterior angles, what this means is that if we take, I'll go back to the example hexagon, and you extend out the sides. So if we extend the sides out like this, right? These outside angles that I'm labeling right now, these are called the exterior angles. And the most interesting and usually the only thing you really need to know about these angles is that their sum is always 360 degrees. No matter how many sides the shape has. It doesn't matter doesn't matter how many sides there are, how many obtuse or angles are there. Anything, it doesn't matter. It's always 360 degrees. And I guess I can show you though. I won't show you the entire proof. I'll give you the concept for it. Essentially, since you know that this is the angle measure for, I guess this doesn't work for all versions of the shape, but for a regular version, since this is the angle measure, then you know that 180 minus this angle is going to be equal to the exterior angle, since these two angles are supplements. They're supplementary angles. So then this is just the measure of the exterior angle, and you multiply by like the total number of angles. And if you evaluate this, it's just 360. And of course, there is a generalized version of this that would actually prove it, but the concept remains the same. So I'll leave it as that. So I guess one last thing before I'll stop for like 4 questions, I guess, is parallel lines. So recall the warm up where we had something like this, and we found that angle 1 after the labels. Let's say the labels look something like this: 1, 2, 3, 4, 5, 6, 7, 8. And you saw that 1, 3, 5, and 7 were all equal in measure, and 2, 4, 6, 8 were all equal as well. And this is largely a property of parallel lines. So by parallel lines, I mean 2 lines that will never intersect. So like it's hard to kind of explain in other ways, actually. There's just 2 lines that don't intersect. The reason why parallel lines work in this case is that essentially what happens is the corresponding angles in like the intersections formed by like parallel lines are always going to be the same. So angle 1 and angle 5, they're like corresponding, like they kind of match like in the respective places on each line. Same with 3 and 7. That would kind of be it for parallel lines. I mean, you can see the same thing for 2 and 6 and 4 and 8. And one last thing, actually, it's something called vertical angles. That is also pretty helpful. Vertical angles. So it's just that if you have any two lines that intersect, then the opposite angles are going to be equal. So these two angles are equal, and these two angles are equal. So I don't know why they're called vertical angles, but just know that the two opposing angles are always going to be the same. And this is also can be seen in our warm-up with 1 and 3 and 5 and 7. They're vertical angles. And I'm not too sure if there's any more kind of theory to go over. So yeah, at this point, if you do have any questions, please ask. If you think that this is too easy, also say so. Just any kind of comment is welcome. All right, well, I guess we can move on to the next part. I've always found that with angles, it's a lot easier to kind of understand the concepts just in problems rather than through definitions anyway. So here you have a question. If the supplement of an angle is 5 times the complement of the angle of the set angle, how many degrees is it the angle? So I'll give everyone like a few minutes to think about this, and then we can kind of discuss. So I see that quite a few of you have gotten the answer. So for everyone else, I think we can go over it. So this question essentially just tests whether you know what a supplement and a complement is. And so the answer is 67.5 degrees. A supplement of an angle x is 5 times the complement of angle x. So of course you can't just stare at the question and magically find the answer. You have to kind of write things down and work through things step by step. So first, the supplement of an angle simply means that when you add it to x, you get 180 degrees. So the supplement would therefore be 180 minus x. And the complement of an angle is what you add to an angle to get to 90 degrees. So that would be 90 minus x. And of course, we have 5 times here. So take the 5 as a multiplier. And then complement of x is 90 minus x. And so this just becomes a one variable linear equation, which I'd expect everyone to be able to solve. And so we work the steps. I mean, d minus x equals to 450 minus 5x. And eventually you'll simplify down to 4x equals to 270. And so you could have simplified this to 135 over 2 or 67.5 degrees. All right. So are there any questions on this problem? All right, let's move on to the next one, which is this. So just take your time and get through it. Yep, I'm seeing a lot of people with the right answer. It's 104. So I don't think we need to spend too much time on this. It's simply just a combination of vertical angles and a line summing to 180. So BOT is 47, MOG is 29, and we defined DOP. And so angle DOP is equal to angle TOM because they're vertical angles. And since this line VG is a line, that means that these three angles at the top must add to 180. So the answer is just 180 minus 47 minus 29, which is equal to 104. Right? So you'll see a lot of these problems are going to be just pretty simple angle, just finding the angles based on kind of missing information. Right? So next we have this. All right, I think we can start to go over this. I saw a few right answers, a few wrong answers, so that means this must be an interesting enough problem. So essentially, it's asking to find angle GIB, which is this angle right here, and it's simply the difference between this angle in the hexagon and the smaller angle in the pentagon, right? So as I wrote earlier, I guess I did kind of do it a little bit messily. You can find the angle of a regular polygon with the formula n minus 2 times 180 divided by n. And the top part represents the sum of all the angles in the polygon, and this bottom part represents the number of angles in the polygon. And so you can simply plug in the values for side lengths. So hexagon is 6, a pentagon is 5. So if n equals 6, this is 4 times 180 over 6, and this is equal to 120. If n equals to 5, then this is 3 times 180 over 5, and this is equal to 180. And so angle GIB is simply the difference between 120 and 108, which is 12 degrees. And so as you work more with these kinds of shapes, I do recommend simply memorizing these values like 120, 108. They come up a lot, and you know, I think you don't have to go every way to memorize it. You'll probably just pick it up along the way, but it does help save a little bit of time so you don't have to use this formula. Either way, it's still pretty quick, so as long as you know this, you should be okay. All right. So are there any questions on, I guess, this solution? And for everyone who did not get the right answer, I hope you can see what you did wrong. All right. Let's move on to the next one. So read the problem. This meeting is going to end in about 2 minutes. So I won't start explaining the solution. So just take the time to work on the problem. And once the meeting ends, and I'll restart it, everyone rejoins, and then we can talk about this problem. So just take the remaining 2 minutes to just work through this. All right, I'll see you in the see everyone in the next Zoom meeting. So be sure to rejoin. Let's get back. All right, so I guess we can start discussing, as I think everyone actually had the right answer here. So the answer is 143. And I guess with this problem is more of trying to deal with, I guess you're given more information than you actually need. So there are many ways to actually do this problem. And so I guess I'll go over, I guess, two ways you could approach this. So the first way is through using that all the angles add up to 360 degrees because circle is 360 degrees. So you're given this angle is 127. And since GRM and MRT are complementary, this means that this is 90 degrees. So this remaining angle that you need to find is simply 360 minus 90 minus 127, or 143. This is, I think, the quickest way. I think another way you could have done it is by using supplementary angles with TRY and TRM. Since TRY is 127, TRM is 180 minus 127, which is 53. Right. And then with 53, 53 and this other angle, GRM, they must be complementary, so they add up to 90. That means GRM is 90 minus 53, which is 37. And then you can work with supplementary angles again with GRM and GRY. And that's 180 minus 37, which is again 143. So there are multiple ways to do this problem. It's just find whichever way that you think is easier for you. All right. Yeah, there's the answer. That's okay. Well, either way, I'll work through this problem and we'll discuss. All right. Seeing that quite a few of you have gotten the right answer. It was 117. Anyway, so why is it 117? That's one point. This is simply just complementary angles and then parallel lines. So if you recall that a triangle is 180 degrees, so that means that this angle DCB and angle CBD add up to 90 or are complementary. So they're not like next to each other adding up to a right angle, but they do add up to 90, so they're still complementary. So this angle is 27, and oh, that is okay. That means that this is 90 minus 27, and 90 minus 27 is 63, right? And then we want to find angle DGF, right? So the best way to like look for angles that you don't know. Actually, this okay. I'll tell it. The best way to look for these angles is to get like as close to them as possible. So kind of like working your way through the diagram and finding the measures of as many angles as possible, or as few as possible. But so logically speaking, this would be the most reasonable one to do next. Angle DBA, it's supplementary to 63, so it's 117. And now here's the kind of jump you have to make, which is that this line BA and the line GF are parallel. And we know they're parallel because this corresponding angle here and here, they're both 90 degrees, meaning that they're both equal. So there's a parallel line, which means that this angle right here, that's 117, is also equal to DGF because they're corresponding. And so that's how you get the answer, which is 117. And I also noticed another method you could do this, which is this isn't the only right triangle in the figure. CBD is not the only one. You also have CAE, right? And it applies the same like rules. That means that this angle E is 63 because 27, 90 here, this must be 63. Same logic as we used earlier. And also note that this angle, I'll highlight it in a different color, is 90 degrees as well, because this angle and the angle up here, they're complementary. So they add up to 180, and 180 minus 90 is 90. And so you have there's a 90 degrees here, and 90 degrees down here, and 63 degrees here, and this unknown angle here. And since the angles of a quadrilateral add up to 360, this means that this angle DGF is 360 minus 90 minus 90 minus 63, which also gives 117. So just pointing out that there are always, most of the time, multiple solutions to these problems. So just, I guess, be creative and it'll probably work. All right, I believe this is the last one. Yes, okay. So yeah, try your hand on this.
Could you?
Oh, and I do want to point out, in case you don't know, this notation that I'm circling right here, this means that the two lines are parallel. If you see arrows like this in the same direction, it means they're parallel.
Should we do it in degrees or should we just say X or?
That's a very good question. You can, or you should do it in terms of X, I believe.
Okay.
Actually, now that I think about it, you could probably find this in terms of not X, but I think I'll go over that later. So just find it in terms of X and we'll see. The reason why I'm not saying whether any of you are correct is because I'm also trying to figure it out. Okay, let's discuss. I'm pretty sure that most of you are correct in that it is X, but there is actually more to this problem. So let's work through this. First, in terms of X, you'll see that this angle right here is equal to 180 minus 4x, simply because of supplementary angles. And so this triangle must add up, ACB, the triangle, must add up to 180 degrees. So that means that angle C is equal to X. Right? And then, but we're also given this thing called parallel lines, and we never used it. Right? So it only makes sense to kind of figure out how we can use this to our advantage to maybe even solve for the value of X. And it is actually indeed possible to do so. So I have a few suggestions. You can kind of pick which one you think you would go for. So first, when you see parallel lines, your first instinct should be to look for any possible corresponding angles, because those are the ones that are equal and it will give you like the most information. And in this diagram, there are no corresponding angles immediately. But if we extend this line CA past A like this, you'll see that this angle right here is equal to 2x, because
Is X equal to 36?
Yep, it is. And this is because 3x and 2x, they add up to 180. This is a straight line, so these are supplementary angles. 3x, 2x equals 5x equals 180. So x is 180 divided by 5, which is 36. And so that's why this is 36, because it's just equal to x. I apologize for the confusion over this problem, but does everyone kind of get the concept behind this problem though? With it's kind of like multiple steps. So first you can use the more basic angle chasing to find that this is equal to x, and then also use parallel lines to find the exact value of x. All right. Well, anyway, we'll see more problems that are similar to this next week, where we work through the more challenging problems. So I guess you have that to look forward to. Are there any questions on this question just right now before I move on?
If you have a problem similar to this, how do you know if you're supposed to express it as x, as in terms of x, or in terms of degrees?
Usually the problem will be more specific, but I guess in this case, I would say that the only way you can know for sure is just by like using all the information given in the diagram. So you'll see that to find the x, we never actually use the parallel lines, which is why I determined that you could probably actually figure out the value of x. But unless like they don't tell you anything, then you can probably just get away with only solving in terms of x. Yeah. So long answer short, they'll usually tell you, and I guess I said the wrong thing, but you know, we all make mistakes, and at the end of the day, if you work on a problem for long enough, you'll be able to figure out whether it's actually possible to solve in terms of x. Sorry, to actually find the value of x. I hope that made sense. Okay, well, this was the last problem, but we're not actually done for today. So yeah, I have this empty slide because I figured that we might have some time at the end, so I thought I could go over some other cool geometric stuff that would be pretty useful. So I guess just, I can't really do show of hands, but like, it's in the chat, like, does everyone know, or has everyone taken like a geometry class in school?
Do you mean like real school?
Just any kind of school, any kind of geometry class. Has everyone, it's okay if you have it. So like, does everyone know like, okay, no, okay, that's fine. So this is actually why we have this class. And I might go over this, okay, well, I'll go over this a bit more next week too, where important things to know in geometry other than this angle stuff that I went over. So first is this cool thing called the Pythagorean theorem that if you may or may not know, it's like a squared plus b squared equals c squared. This is the most commonly tested geometric concept in most of these beginner contests. You'll see like this a lot, yeah, 3, 4, 5. If you want me to elaborate on any of these topics, please do let me know. I'm just saying this as kind of a broad overview. Another one is the area of a circle. So pi r squared is the area of a circle. This is very important to know. I guess what else? There's actually a lot more depth to circles.
What about the circumference of a circle?
Well, what is it? Does anyone want to let me know what it is?
dr. No, wait. T pi. D pi.
It is d pi or 2 pi r. And this you'll actually be able to know the reason why in more advanced math. But I think that these two things are like the two like main main things. Other things you might see are like the area of a triangle, area of a circle, not circle, area of a rectangle, parallelogram, that kind of thing. So you should probably know how to calculate the areas of these shapes. And that's just base times height over 2 for a triangle and length times width for a rectangle. Yes, those are all Pythagorean triples. So again, if anyone does have any questions on what I just said, please let me know. I feel like you don't need to know too much about like geometry, but as long as you're familiar with these concepts, I think you should be okay. And if you do want to learn more about, more in depth about like this geometry and maybe three-dimensional geometry, you can always send me an email. I do have more extensive resources on all of these topics if you are interested. All right. Also, I do want to say that the recording for the last class is actually not on YouTube right now. There were some delays on our end, so I do apologize for that. But hopefully it should be up soon. And the same goes for this week as well. So again, if you do want to review anything, make sure to check out the YouTube channel. And okay, last thing, which is previewing next week. So next week, it's actually the same slides. Next week we'll be doing the challenge problems. So they're just there's not gonna be anything new, just in theory harder problems. So challenge problems. Here are like the examples and the answers, but you won't remember them anyway. So like anyway, this is what we're gonna be doing next week. So I guess just be prepared for that, or don't be prepared for that. I mean, we're gonna go over everything anyway, but just something to look forward to. All right, so 58. I guess I'll let you guys go a few minutes early. So
thank you.
Yeah.
Bye.
Bye. Have a good day, everyone.
Bye.